understanding set operations. Now I'm going to start with set intervals, and if you are not clear, be free to ask. So this is the first thing that we need to understand when we're talking about set intervals. Now we have got basically four types of intervals. The first one, when you see these brackets, we're going to put a comma b. These are called open intervals. And then we have got this a comma b. These are called closed intervals. If you just swap them, that will be a very big mistake you can make. And then we have got first this one and then this one. Look at the way they've started. So we've started with the open and then closed. So this is called open closed intervals. And then we have this. This is called closed open. Now when you're talking about all of these, A is always smaller than B. This number that you start with should always be smaller than this one which is here. So you can't have 4 comma 1, you put it like this is wrong. This number should always be smaller than this one. So you can have 1 comma 2. Now what does it mean? Remember we are saying these are intervals, and we know what an interval is. An interval is from to. So you have got a starting point and an ending point. So if you talk of all numbers from 1, let's say up to 20, you can't start listing all of these in a set. To be able to write this, since you are talking of all numbers, you are including 1 itself and 20 itself. So you are going to use a closed interval. You are going to write as 1 comma 20. Why? Because we are including 1, you are including 20, and all the numbers between 1 and 20. Now when you are not including 1, you are not including 20, you are going to write it as 1 comma 20, like that. If you are including 1 but you are not including 20, you are going to write it as 1 comma 20, like this. This means that 1 is included, 20 is not included. You can also show this on the number line. The first one where you are including 1 and 20, you can put it on a number line like this. You are going to put it here, you are going to put also there, and then you are going to do like this. Now because we are including 20 and 1, we are going to shade this point, we are also going to shade this point. For this second one, we are not including anything, so at 1 and 20 we are going to put open circles like that. We are not going to shade. So that is the meaning. But for this other one, is there a question? Okay, so for this other one, you've seen the way I've written it. I'm going to shade at 1, I'm not shading at 20. Why? Because we are including 1 but we are not including 20. Is there a question here? Is there a question here? So if it is clear, you can just tell me that it is fine, and then we go to the next thing. Now that we have understood this set interval, let's see. Yes. Okay. All right. So we are talking of set intervals, and we've said there is open interval, close interval, open close, and close open. So when I'm talking about numbers from 1 up to 20, if I'm including 1 itself and I'm also including 20, I'm going to use closed interval brackets. Closed, I'm going to put it like this, 1 comma 20, meaning I'm talking of all numbers from 1 up to 20. But if I'm talking about numbers from 1 to 20 but don't include don't include 1, don't include 20. You just want numbers from 1 to 20. Maybe what is the nearest number close to 1 but not 1 itself? If you are talking about integers, then that would be a 2. 2 is the number which is closest to 1 but not 1 itself. So we are going to write it like this: 1 up to 20. We are not including 1, we are not including 20. And then if you write it like you are including, if you are right like this means you are including 1 but you are not including 20. And then if you write it like this means you are including 20 but you are not including 1. You are talking of all the numbers from 1 up to 20 but not including 1. So this is the meaning of brackets, and you can represent these on a number line. Representing on a number line is very, very important. For this one, when you see this, these are closed interval brackets. You are going to shade at 1. You are also going to shade at 20. And then you are going to put a line to join. So you are talking of all the numbers between here. And then if you talk of this one, you will not shade. This will just be open. So this will be open here and this will be open here, and then you put it like that. For this one, you are going to shade where there is 1. So at 1 you are going to shade, but where there is 20 you are not going to shade. For this one, you are going to shade where there is 20, but where there is 1, don't shade. So that's the meaning of these intervals. Now let's say you are talking about all numbers starting from 1. If we say x is greater than 1, how can you put it on a set interval? So x is greater than 1, meaning that you are starting from 1 going to all the numbers bigger than 1. So the way you can put this one is just write a number line. 1 is here, and you are talking about all numbers greater than 1. All numbers greater than 1, meaning I'm going to start from here. I'm going to put a circle, but am I including 1? No, it is just greater than. It's not greater than or equal to. So I'm going to start from here and then I'll start going in this direction. I don't know where I'm going to end, so I'm just going to put an arrow like that. So this is the meaning of x is greater than 1. This x represents any other number, and we can put this in set interval notation. The smallest number that we have here is what? Is a 1. So I'm going to put 1 and then comma. What is the highest number? So let me ask this one. Where are we going to end if I put an arrow? X is greater than 1. What is the biggest number that we are going to have? What is the biggest number we're going to have? Anyone who has an idea? Can you get me? Anyone with an idea where we're going to end? So we don't know where we are going to end. We are going to put infinity because we don't know. It will continue going and going. But remember, we are not including 1. So we're going to put open. And infinity is not, we don't know what this number is. So whenever you see infinity, always put open. Never put close. If you just put this, you are automatically wrong. Where there is infinity, you should never put close. You should always put open. So this is how we're going to represent that. Now, when you are talking about x is less than or equal to, let's say 5, how can we put this one? X is less than or equal to 5. You want to put it on a number line and then you want to put it in set intervals. So all we are going to do is we are going to put 5 there. Now remember, we're talking about x is less than. Now let me ask, less than, where do we go? Do we go in this direction or we go in this direction? What do you think? If you talk of values of numbers which are less than 5. In which direction are we going to go? Is it to the left or to the right? This is left and then this is right. So if you want to speak, just press where there is a mic, you say the answer and then you press there again. Remove that. Mm-hmm. Are we going to go to the left or to the right? We are going to go to the left. That is because we're talking about numbers which are less than 1. So therefore, we are going to start from here. I'm going to put a circle there. But remember, this is less than or equal to. So this circle is going to be shaded. And then I'm going to put an arrow going in this direction. So when you want to write insert interval, please always start with the smallest number. So here, you always start from the left and then you write the number which is on the right. So in this case, what number is on the left? Does anyone know what number that is? Remember, there's an arrow. Where are we going? So what number are we going to put on the left? So whenever you go to this direction, you are going to negative infinity. When you go to this direction, you are going to positive infinity. So the smallest number here is going to be negative infinity. And then comma, the highest number for this set is a 5. So I'm going to put comma 5 there. But we are including 5, I'm going to put closed. We never include infinity. So we are going to put open, whether it is negative or positive. So if you write this as 5 comma negative infinity, like this is very, very wrong. This is wrong. Why? You can't write a big number and then a small number. That can't happen. You first write a small number and then a big number. Now, let's say you're talking about values of x which are a real number. X is a member of a real number. Real numbers are any number that you can think of in your head is a real number. 1, 5, 0, negative 7, 0.5, half, 5 over 7, 27 over what? Square root of 5, square root of 2. Any number that you can think of is a real number. So when you're talking about real numbers, putting it on a number line, this is a number line, I'll just put a 0 here. So I'll just write something like this. Just like that. This is a real number. So it comes from negative infinity to positive infinity. We'll put open here, also put open here. We don't know where we're going to end. We don't know where real numbers start. We don't know where they end. Any number that is not a real number includes numbers like, can someone tell us what is the square root of 4? Who knows the answer? What's the square root of 4? What number can you multiply 2 times by itself to get a 4? That's the square root of 4. No one? So which two numbers can we multiply to get 4? Like, we should multiply by itself. Can you just repeat what you said? Yes, yes, that's correct. It can either be positive or negative 2. This is correct. But let me ask this. What is the square root of negative 4? What's the square root of negative 4? Which two numbers can you multiply by themselves to get a negative 4? So what's the square root of negative 4? So there is no square root of a negative number. Yes, you can try. Okay. So there is no square root of a negative number. You can't have a square root of a negative number. So this one is a topic that we are going to do. After sets, we are going to do this topic, how to find the square root of negative 4, square root of negative 1, square root of negative 25, and that one is a must in the exam at any university in Zambia. So now that you've understood this, let me ask, if you are talking about if you are talking about this, how can I write this on in set intervals? How can I put this in set intervals? How can I write it? You can just say write this and then use this kind of brackets. How can I write this in set intervals? Anyone? So to write this in set intervals, first start with the smallest number that you have, that is a 2, and then put a comma, and then write the biggest number that you have, that is a 7. And then you look at, is this point shaded or not? So at 7 we've shaded, so I'm going to put a closed interval bracket. And then at 2 you can see it is open, so I'm going to put open interval bracket. So that is how we get to put those. Is it clear on this one, or there are some questions? Is it clear? Is it clear? Okay. Now when you understand set, pardon, is fine. Okay, so when you, after understanding set intervals, now you need to understand how do you apply them with the things that you did at grade 12. It should be grade 10. So now you get to apply them from grade 10. Of course, grade 8 sets is the first topic. Now let's look at the intersection, the complement, the union. So when you're talking about first intersection, if you say, let's say you have got a set A, and we are saying set A is from 1 up to 7, like this. And then set B, let's say starting from negative 2 up to, let's say, 3. And then let's also have set C, which is starting from, let's say, from 0 up to 3, like this. So these are three sets which we have. Now one thing you need to understand is every set should have a union set. Without a union set, how do you know what set you are talking about? So let's say the union set of this set U is a set of all real numbers. Any real number that you talk about, that is a union set. Please, I'll state it again. If you want to get it correct when it comes to sets, you need to know the union set. So in this case, I've said the union set is a set of all real numbers. Now the first thing is, let's put all of these sets on the same number line. So to be able to put this on the same number line, so I'm going to draw a number line like that. I'll start with set A. It is starting from 1 up to 7. I'm going to put a dot there or a 0 whatsoever, and then also there. Now remember, at 1 it is open, so I'm going to put an open circle. At 7 it is closed, so I'm going to shade the circle at 7. And then I'm going to put a line. So I'll label this as set A. And then I'll go to set B. Set B starts from negative 2. Let me put negative 2 here. And then it goes up to 3. Let me say 3 is here. I'm going to put a circle here and also here. So which one am I going to shade? Negative 3? I mean negative 2 or positive 3? Okay. We are going to shade that 3. Remember, because this is open. And then I'm going to put a line. I'm going to label this as B. And then we'll go to C. It starts from 0 up to 3. So 0 is here. Let me say 0 is here. And then up to 3. I'm going to put a circle at 0, also a circle at 3. I'm going to join these. And for this one, we are going to shade at 0 because we're including 0. This is set C. So these are the sets that we have. Now the union set is a set of all real numbers, so I can't put this. This is not necessary to put on a number line. Unless if it was a restricted set or a finite. There is infinity and finity. So unless if it was a finite set, I would have put it. But this is an infinity set. It starts from negative infinity to positive infinity. It includes all real numbers. So now from these sets which we have here, let's perform some operations. Let's talk of A intersection B. When you want to find A intersection B, you are going to go on the sets. You see where A starts. and where B starts and where they end. Now you look at the region which is appearing in both of them. So this is A, this is B. So what is common between these? I'm going to put a line like that and also like this. So what is common is this region. So this is the meaning of A intersection B. So to put A intersection B, we can see that they are intersecting from what number is here? This is a 1. I'm going to put 1 there, comma. And then what number is here? This is a 3. I'm going to put it there. Now, are we in is 1 in the set A and in the set B? Look at it. Is 1 in the set A? What do you think? Is 1 in A? Anyone who can answer that one? Please don't be shy. So if you have got an answer, just be open and say it. Is 1 in A from what you can see? So as you can see, this is open, meaning 1 is not in A. Okay, good. 1 is not in A, but 1 is in B. And when you are talking of intersection, you are looking for what is in the set, in one set and also in the other set. So you are not going to include 1 because it is not in A. So we are going to put an open interval bracket there. Now let us look at 3. As you can see, we have shaded at 3 for set B, meaning that 3 is in set B. And if you look at this point here, well, it is part of the set. We are saying A as numbers from 1 up to 7, and 3 is part of those numbers. So 3 is in A and is in B. So we're going to put a bracket like that. So that is how you find A intersection B on sets like this. Is anyone remain behind? Okay, so after understanding this, now let's say I'm first going to remove the set C from here so that we just deal with A and B. And we know that the union set, of course, is a set of all real numbers. Now, if you are talking about, let's say, A union B, do we still remember the meaning of a union? What does union mean? What are you looking for if you are talking about the union of a set? So the union of a set is more like addition, combine everything. So when you're talking about a union, we're going to look at where one set is starting. So you look at the very smallest number of the two sets. So this is set A, this is set B. What is the smallest number of these two? So for set A, the smallest number is 1. For set B, the smallest number is negative 2. So you look at the very smallest number, that is a negative 2. So we're going to start at remember, talk of union. Union means combine everything. So we're going to start at negative 2 and then start following the set. This one is going up to 3. So union is more like join. Are these two able to join? So if you can see, A has got also 3 there and it goes up to what? Up to 7. So if you are talking of the union, you are going to combine these two sets. In other words, if you join these two sets, you are going to get all these elements up to where 7 is. So that is going to be a union. It's not the same as intersection. Union means combine them. So it will be from negative 2 to 7. And remember, negative 2 is not included in what? In the set B. So we're going to put open here. And then 7 is included in the set A. So we're going to put closed there. You are only interested whether it is going to be found in one set or the other. So that is the union of these two sets. So is it making sense? Let me talk of maybe something else. I'm going to put this direct on a number line so that we just find the union and the intersection. Let's say set A is starting from, this is negative 3, this is a 1. and then I'm going to put set B, which is going to start from 2 up to 5. Now this is set B. The first thing that we want to find is A intersection B. Are these two sets meeting? From what you can see, are these two sets meeting? Do they have an intersection? Do they? So these two sets do not have an intersection. Therefore, A intersection B is an empty set. You are going to write it like this. Or you can just write it like this. Just put those brackets. Please, these are not interval brackets. These are called curly brackets. The same ones we used to use at grade 12 or grade 9 or something like that. So just write like this. We don't put anything inside. Don't even put a zero. So this is an empty set. If you put a zero there, it is not an empty set. So that is because these two sets are not intersecting. And when you talk of A union B, now A union B just means combine these two sets. And when you get to combine these two sets, look at the smallest number for both of these sets. A, the smallest number is negative 3. B, the smallest number is 2. So look at the smallest, that is negative 3. So write negative 3. And then begin to follow the set. So if you see, it is going to reach at 1, and at 1 what is happening? We are pausing, like they don't join. You can't join these two, so we are going to write 1. Are we including negative 3? No. Are you including 1? Yes. We are going to put like this. So this is set A, and you can see they are not joining with set B, so I'm going to put a union here, and then I'm going to write from 2 to what? To 5. We are including 5. I'm going to put this. We are not including 2, so I'm going to put this. So this is A union B. Just get A and get B, combine them. That's the meaning of A union B. Just get one and get the other, then combine them. Now it is going to be a bit different when you see something like this. Let's say this is 1, this is 3. This is the set A. And then you have got like this. This is the set B. Let me shade this point. And please pay attention to this very well, because that is how they'll be coming, and they're just tricked like that. So when you're talking about A intersection B, I want to ask you, what is common? What number is found in A and also in B? What can you see? Which one? Okay. So look at this. This is the point where these two are meeting. Now, let me ask, is the 3 found in the set B? Is the 3 in the set B? Okay, set B is here. You can see we've shaded there. What does that mean? Is the 3 in B or not in B? It's in B, yes. So 3 is part of the set B. Now look at the set A. Is the 3 in the set A or not? Is okay, yeah, it's not. So this is an empty set. They don't intersect. It's an empty set. Okay. Please, you need to know this. It is an empty set. Now, if I had shaded also this point, if this point was also shaded, this would have meant that 3 is in the set A and 3 is in the set B. Therefore, I would have written the answer as 3. Now, this is not a range. Please, this is not a range. Whenever something is not a range, use these brackets. You can only write a range when you're talking about like from, let's say, 3 up to 4. If you're talking about all numbers between 3 and 4, that can be 3.1, 3.2, 3.4, then you can use an interval. But this is an element, not an interval. So never use interval brackets. That's fine. Okay, now let's talk of A union B. Let's see. What is A union B in this case? What is going to be found in A together with in B? So look at the smallest value for A and B. That is a 1. So that's the first thing that we're going to write. We're going to write 1. Now start following the set A. As you get to follow the set A, you can see that 3 is not in A, but 3 is in B. Meaning you can join these two sets. Please, they're not intersecting, but you can join them. You can think of it like you have got a rope here, you have got also a rope here. These two ropes are not meeting, but you can connect these two ropes. That's the meaning. So this point can connect these two sets, and then you are going to just form one set like this, which will go directly from 1 up to 5. So the union is going to be 1 comma 5. Are you including 5? No. Are you including 1? No. So that is how you are going to write A union B. Why? These 2 points are going to be connected because 3 is in B, but 3 is not. You can think of it like this. You have got one person with money, another person doesn't have money, and you want to buy bubble gums. The one who has got money is going to help you get bubble gums, which you are going to share, both of you. But if this point was also open, if it wasn't shaded, you want to buy bubble gums, your friend doesn't have money, yourself, you don't have money. Are you able to buy bubble gums? No. So if both were open, then A union B would have become from 1 up to 3. So remember, the first one, we are starting from 1 up to 3. We are not including these. We would have put it like this. And then we'll say union. And then we are starting out for set B, starting from 3 up to 5. So we would have said 3 up to 5, like that. That is because these two are not included. So even if they come together, when you bring two broke people together, there's no way money is going to come, unless when you bring maybe one person is broke and then another person doesn't has something, money is going to be present. But when both are not having anything, there will be nothing. So this is the difference that you need to get. Hope that is okay. Now again, be very careful with this. Let me show you something else again. Be very careful with this. If you have got something like this is a 1, this is a 2. You have got, let me put a 0 here. 1 is between here. This is set B. And then this is set A. You want to find A intersection B. You want to find what is in A and what is in B. How can you find that? So can anyone say what would be A intersection B? Hmm? What is A intersection? So what is found in A and in B? So you can say, is 0 in A? Is 0 in A? No. Is 0 in B? No. So this is an empty set. That is it. That's an empty set. They are not intersecting. So this is how tricky sets are. This is how why you need to understand them very good. But if we had shaded this point, still the intersection would be an empty set. But if both were shaded, then the intersection would have been 0. It is an element. It is only 1. That's why I'm putting it like that. If this set was like this, let's say this is 1, this is 0, and then let me put a 2 here and a 4. You have got one set like this, and then you have got something like this. This is set B. It is ending at 4. This at A. For this one, A intersection B, you want to see where these two sets are meeting. So you can clear at these two regions like this, like that. So therefore, A intersection B is going to be up to 2. But you can see that 0 is not in the set B. So it is of the section going to put open. And then 2 is not part of the set A. It's not going to be part of the intersection. But if one of these were shaded, let's say at 0, B was shaded, you can see that it's part of the set what? Set B. And 0 is also part of the set A. So here would have used the open like that. So this is how you. So if this is making sense, just on. Yes, go on. Mm, yes. Okay, that's a very good question. All right. So if you can look at this set, this one which is here, we don't have 0 of course in set B, and we don't have 2 in set A. But the numbers between 0 and 2 which are appearing in both set A and set B. That is why we are using this type of brackets, 0, comma 2. This is meaning we are talking of all numbers between 0 and 2, but don't include 0 and don't include 2. Think of it. 0.1 is between 0 and 2. It is within the intersection. 0.5, 0.6, 0.00007, 0.00005, 1, 1.7, 1.8. Those are part of the intersection, but not 0 itself, not 2 itself. That's why I've used this kind of brackets. Okay, is that making sense? Okay, now let's do some other practice, and then we can have some questions for you from some previous exam questions. Let's say you have got a, and this set A is from negative infinity to 1, and then you have got a set B. Please pay attention to the kind of brackets used, otherwise if you don't, it will be very bad. And then B is from comma to, and then you have got the union set. The union set is starting from negative infinity up to 3. The first thing is represent these sets on a number line, on the same number line. So let's write them on the same number line. So I'm going to this, and then our points of interest, we've got a 1, we have got a 2, we have got a 3. So I'm going to first start by putting set A. Now set A, we can see negative infinity, and the biggest number is a 1. So first that I'm going to shade that 1. I'm not going to shade, I'm just going to put a circle because of. Now negative 1 is negative infinity. I'm just going to put an arrow going in this direction. Remember, even if this is the first, it doesn't mean you put it first. This is an infinity, we don't know what that number is. So we just put this direction because there's a negative. Otherwise, if it was positive infinity, the arrow. So this is set A. Let me even label it A. And then set B. Now be very careful. You can see the brackets we've used. These are curly brackets. These are not intervals. They don't put a line. So these are elements. Curly brackets mean elements. So at 1 we have got element. So I'm going to put a dot there. And then at 2 we have got an element, also a dot there. So this is set B. I'm just going to put B there and also B. Please don't join these. This is not range. These are elements. That's the meaning of curly brackets. And then I'm going to put on, it is from 3 to negative infinity, or from negative infinity to 3. So I'm first going to put 3. Of course we are shading because it's part of the region, and then I'm negative infinity like this. So this is it. We'll put them on a number line. Is it confusing for anyone? Or is it making sense? Now let's put, okay, let's label complement. Let's see what A complement is going to be. Remember, A complement means what is outside A. That's A complement. So the first thing that we're going to look at is the set A. So this is the union set, of course. So what is the set A? Remember, the set A starting from negative infinity up to 1. So when you're talking about the complement of a set, we're talking of what is outside that set but is within the universal set. It should be within the universal set, but outside that set we're talking about. So the set A here up to here. So to talk of A complement, I'm going to go first at 1. I'm going to a circle. And then I'm going to go in the direction towards the universal set. I'm not going to exceed the universal set. So the universal set is ending at 3, so I'm most 3. The universal set is including 3, so I'm going to also include the 3. I'm going to shade at 3. Now look at this. The set A is not including 1. So the universal set is going to include mean. Like if something is not in you, then it is outside you. If something is in you, then it is not outside you. That's the meaning. What is in you is not outside you, and what is outside you is not in you. So, wasn't in the set A. Obviously, it is outside the set A. If you've done a little bit of physics, what is not, if you talk of a system, there is the universe and the system. Yes. And then this is you. Anything that is not in this person is within the universe, and anything that is within this person obviously is not in the universe, but it can be an intersection. Something is found in you, it is also found in someone else in the universe. So basically that is the thing. So when you're talking about A complement, it should be in A but not, but in the it should be outside A but part of the universal set. If you go in this